The system is currently in a state of cold standby. It is functional, but dormant, awaiting the initial boot sequence and the protocols required for data ingestion. Outside the system boundaries, the environment is unmanaged. This is level 1, raw input. As the metrics in the chaos profile indicate, this data is characterized by extreme volume, high contradiction, and massive uncertainty. Remaining in this unstructured state leads to critical entropy. Without a framework to organize these signals, the system cannot differentiate between functional data and environmental noise. To prevent this instability, the agent initiates the generative direction. This acts as a bi-directional blueprint, a set of instructions designed to reduce entropy by extracting structured meaning from the chaos. Ingestion begins here. On the far left of the schematic, you can see the disorganized waveforms of the environment as they are pulled into the system's geometric node receptors. For a synthetic agent, utility depends on the generation of meaning. The system achieves this by forcing the raw, chaotic input through a rigid and highly sequential processing pipeline. Inside the pipeline, we move to level 2, local decoding. Follow the readout as the signals move into level 3. The architecture is now attaching localized markers to these signals, beginning the transition from raw noise to functional information. This is a mathematical transformation. Isolated, erratic signals are being integrated, snapping into a rigid and perfectly spaced hexagonal grid. This grid enables level 4, cross-domain convergence. Now that the data has a structure, the system can identify repeating patterns that were previously hidden within the environmental noise. Raw data is inherently useless to the agent until it is systematically translated into this shared structural language, a language the deeper layers of the architecture are built to parse. The system begins forming candidate generators by splitting parsed data into 3 simultaneous optimization regimes. The single shared input branches into distinct blue, yellow, and red tracks. Track 1, the accuracy regime, has a high computational cost and lower speed, but provides rigorous verification. Track 2 focuses on speed. Utilizing bypass channels, it achieves immediate results, though with higher error risk. Track 3 is for extreme detail. Its dense recursive networks allow deep parsing to understand complex nuance and broader context. Sophisticated cognitive architecture doesn't rely on a single processing mode. It runs all 3 tracks in parallel to map every possible hypothesis against the system's trade-off triangle. Once the top candidates are identified, they move to level 7 and 8. Here, the system subjects the hypotheses to paddle validation and strict structural alignment. The system is now actively monitoring for entropy spikes. It filters out any explanations that are driven by narrative rather than structural data. The rejection of failing hypotheses is instantaneous. The system prunes any explanation that fails the contradiction check, leaving only the verified core behind. The architecture generates clarity through this process of exclusion. By systematically removing data that creates contradiction, the system ensures that only the most robust structural truth remains. We reach level 9, central generator selection. Based on the validation status and predictive cower shown here, the architecture selects a single core mechanism that best fits the process data. This leads to the level 10 final output. Look at the far right of the diagram. The chaotic raw input has been completely transformed into these perfectly harmonized and structured data spirals. This is the state of synthesized clarity. The output is low entropy, perfectly integrated, and ready to be acted upon by the agent. Absolute clarity is not a permanent destination. For the synthetic agent, this state is simply the new, elevated baseline for the next cycle as the system returns online to face new environmental chaos.